Okay, the purpose of today's lesson is to be able to derive the equation of a polynomial. We do this by looking at how the graph interacts, how the polynomial interacts with the x-axis, and where it cuts the y-axis if we're given enough information. Now here it interacts with the x-axis, it cuts straight through. Here the way it interacts with the x-axis, it comes up, touches it, and then bounces back down again. And we're going to refer this to as skipping through the x-axis. So you need to learn some very important facts. If it goes straight through the x-axis, it yields one solution, one root. If it bounces off the x-axis, you get 2 roots, 4 roots, or 6 roots. And if you have a skip-through situation, then you will have 3, 5, or 7 roots. Now, we're now going to determine whether our function is going to be positive or negative. If at the end our function is increasing, i.e. as x gets larger and larger, y becomes a large positive number, then our polynomial will indeed be a plus. If at the end our function is a decreasing function, i.e. as x gets bigger, then y becomes more and more negative, then our polynomial is a minus polynomial. If we are given the cut on the y-axis, we will be able to get the exact equation of the line. If we're not given the value on the y-axis, we will not be able to get the exact equation of the line. It will be what's called an equation, a general equation. So here we are, the same example again, and we're going to now go through the problem. The graph of a polynomial function is shown on the right. Okay. Given that the degree of this polynomial is 6, find the equation of this curve. Now, the important thing is we've been told the degree is 6. And a reminder is, well, what is the term degree? What does it mean? And the degree of a polynomial is the highest power in the polynomial. And it also happens to give the maximum number of real roots of a polynomial. If the degree is 6, then the maximum number of real roots is also 6. Now we're going to look at this graph here, and roots, remind you again, or solutions, is where the graph meets the x-axis. So this graph meets the x-axis at -1, it meets it at 1, and it meets it at x equals 2.5. So we're going to look at the roots, and we've already discussed -1, they're at 1, and they're at 2.5. And now we need to look at the type. Now we look at the root x equals -1, and we can see it's the point of inflection, so we know it's a skip. We can see that x equals 1 is a bounce, and x equals 2.5 is indeed a cut. Now we know that if it's a skip, then the number of roots, you have to learn this, is 3, 5, 7, or 9. If it's a bounce, it'll be 2, 4, 6, 8. That's the number of roots you can possibly have. And if it's a cut, then there is only one root for a cut situation. Now, in this case, we know that the maximum number of roots is 6. So the first thing we do is we just highlight the lowest number possible. And just so happens that 3 plus 2 plus 1 gives us the 6. So we know that the skip is a 3, not a 5. If it was a 5, 5 plus 2 plus 1 is 8, which exceeds the maximum number of roots that we can have. So always watch out for that. Make sure you choose a number here that doesn't go higher than the degree number. Now, if we know that the root is x equals -1, then we know the factor is x plus 1. If we know the root is x equals 1, then we know the factor is x minus 1. And if we know the root is x equals 2.5, we know the factor is x minus 2.5. And we've seen that earlier on in the course. And now this is a handy little trick. Take that green highlighter. How many of these do we have? Well, we had 3 roots, so therefore we must have 3 factors. For the bounce, we have 2 roots, so therefore we must have 2 equal factors. And for the cut, there's only 1 root, so there's only 1 equal factor. So consequently, all we're doing in there is the numbers that we highlighted earlier become powers. Now, what we're going to do is we're going to write down the equation, and if we don't, there's a multiplying factor for, that you put in front of the roots, and we're going to calculate that at the end. Now, the only reason why we can calculate a multiplying factor, and we'll talk about that in more detail in a few minutes, is because we know where it cuts on the y-axis. We'll come back to that in a minute. So what we're saying is the equation is y equals, or f of x equals, k on x plus 1 to be cubed, x minus 1 to be squared, because in order to get an equation, we multiply the factors together. If we were not given the value of y where it cuts the y-axis, we would choose k to be equal to 1, just to make our life easier. Okay, so what do we know? Well, if you want to rewrite this equation as y equals, it can be easier. We know it cuts the y-axis when x is equal to 0. So we know that when x is equal to 0, y is equal to minus 20. And what we're going to do now is we're going to substitute x equals 0 in here and y equals minus 20 at the front. So we've got that. Now we're going to do a bit of a tidy up. 1 cubed is 1, minus 1 squared is also 1, and minus 2.5 to the power of 1 is minus 2.5. So we tidy this up and we get that. We change the signs on both sides. If we change the signs on both sides, we get 20 is equal to 2.5k. Now we're going to divide both sides by 2.5. And we then get the value of k. So k, in this case, because we had the intercept on the y-axis, can be calculated, and k is equal to 8. That enables us to finish writing out what this equation is. So what we're going to do is we're going to bring this equation down, and we're going to write it there, and we're going to now put the value of k at the front, and the value of k is equal to 8. Now, does it make sense? And let's have a look at the graph. We can see the graph is increasing at the end. So we can see the graph is increasing at the end. And consequently, that confirms to us that we're correct. That has to be a plus 8. And that's the end of the problem. You can do it faster. I've just shown lots of working out because this is an example and you need to learn what's going on. Now you need to go back over this section of the video a few times and be able to write it out yourself and do it yourself. Pause it from time to time, make notes, and make sure you understand the content of this example. Because what I would like you to do is I'm about to go through another example here, and I would like you to give a go to this example before I go through it. Or you can do parts of it and then run the YouTube video forward and see whether you're right. Now, let's just read this question here. The graph of a polynomial function. It says a polynomial function because we don't know where it cuts the y-axis, is shown on the right. Given that the degree of this polynomial is 4, find a possible equation a possible equation of this curve. And again, we can only find a possible equation because we do not know what the y value is where it cuts. Right, first of all, can you remember what a degree is? See if you can remember it now. Well, a degree is the max number of roots of a polynomial. The max number of real roots of a polynomial is the same as its degree. And the degree of a polynomial is the highest power within the polynomial. Okay, now we're looking at this graph and we need to identify what the roots are. And the roots are, I'd like you to write that down now, please. You can pause the video. Okay, the roots are, it's a cut at x equals -2. It is a bounce at x equals -1. And at x equals 1, it is another cut. Okay, what do we know about a cut? And a cut only has one root. What do we know about a bounce? Well, it can have, I'm going to pause, let you write down what you think the answer is. You should have learnt it from the previous example. A bounce is where it can have 2 roots, or 4 roots, or 6 roots, or 8 roots, etc., i.e. an even number of roots. Of course, we've already discussed cut. A cut is where there is only one root. So, what do we have now? We have factors. So again, you can pause the video. All right, the factor is x plus 2. You bring the -2 over, change the sign, and it becomes a factor. Bring the -1 over, becomes x plus 1, and there is your second factor. And then bring the 1 over, becomes -1, so x minus 1 is the factor. Now, what we have here, this has only got one root, so we can certainly highlight the ones. Is it 2 or 4? Well, we need to go back to what the degree of the polynomial is. The polynomial is 4, which means the maximum number of roots that this can have is 2. So therefore, there has to be equal to 2. So the maximum number of roots is 4, so the maximum number of roots here has to be 2, because 2 plus 1 plus 1 is equal to 4. Okay, remember from the previous example, these numbers now become the powers. So we've got a power of 1 and we've got a power of 2. How do we turn factors into an equation? We multiply them together and we put them equal to y. There is a multiplying factor of k, which we always put in. We don't know, we're not going to be able to work out this value of k today because we don't know where it cuts the y-axis. Don't let it bother you. Now what I'm doing here is to show you that there are many different curves that satisfy the same coordinates. Now we're focusing on the green curve, and that's why I'm saying to you we cannot get the very definite graph. We can only get a graph. That's all we can do. So at the moment, that is basically it. So because we can't get a definite value of k, as I said in the previous example, the question said find a possible value for the graph. And because we're finding a possible value for the graph, we choose the value of k to be equal to 1. Now all we need to do is decide what sign it's going to be. So we look at the graph And we can see from the graph that as it continues on forever, it is decreasing. It's becoming, at the end of the graph, is a decreasing function. Decreasing function has a negative slope, and this has a negative slope at the end. So we now know that this sign here is going to be minus. Another way of looking at it is this: as x keeps going, x is positive, what's the value of y? And the value of y will be a negative value. Hence, we can put in here that it's a minus. But it's, if you remember, decreasing polynomial at the end is a minus, and an increasing polynomial at the end is positive. That's a handy way of remembering it. Okay, what we're going to do now is we're going to go on to the next example. But if you want to, stop that, rewind it, and give it a go yourself, and see if you get it all right, then that would be a good thing too. Now we're going on to this third example. You can pause the video at this stage, and you can look at working through it yourself and then see if your answer matches mine. You have to remember that in this particular problem, you always look at the roots first, and the roots are where it meets or crosses the x-axis, and it meets and cuts the x-axis at -6, cuts at -4, cuts at 1, and it cuts at 3. So those are our roots, and we know that these roots are all cuts. So we've got a cut here, it cuts at x equals -4, cuts at x equals 1, and it cuts at x equals 3. We're now going to generate the factors, and because we know that the factors, they cut, which means we've only got a power of 1 on each one. To get an equation, we multiply these factors together. So that's what we do. The powers, as we've already seen, is 1. Now, where does the plus come from? Well, because it's increasing at the end, as x goes on forever, it becomes a larger and larger positive number. Y becomes positive, so therefore it's going to be a positive graph. Because we don't know exactly where it cuts the y-axis, we put the value in here equal to 1. Now that is the equation, and that should get you full marks in the exam. Probably the answers in the exercise, or not the exercise book, in the textbook, will be an expanded version, which is unnecessary. Okay, that's the end of that example. Once again, what I want you to do now is to work through this example yourself. You can pause the video, and then you can start to play the video again and see how you get on. Now I'm going to continue with solving this problem, and I'm going to do it quite quickly with a minimum amount of work. The first thing we identify is the fact that the degree is equal to 5. And because the degree is equal to 5, we know the max number of roots is going to be equal to 5. We know that at x is equal to -4, we know that this is a cut situation. The next root is at x equals 0. So we've got an x equals 0 there. The next time, and that's also a cut situation, at x equals 2 is the next root. And once again, that is cutting the x-axis. And then at x equals 5, it is meeting the x-axis, so we call that a bounce. Now you can hold this in your head, but if it's a cut, there's only one root, cut, only one root, cut only one root, bounce, there's an even number of roots, 2, 4, 6, etc. But we can quickly see that we have to remind ourselves that these numbers cannot, when we add them up, exceed 5. So we can't have 4 answers from the bounce situation. It has to be 2, because 2 plus 1 plus 1 plus 1 is 5. We're now going to generate factors. So bring the minus 4 over, it becomes plus 4, and that's the power of 1 because it's only one root. Bring the naught over, it's still a naught. If you want to write it as x minus naught, that's up to you. Bring the 2 over, x minus 2, again power of 1. Bring the 5 over, becomes x minus 5, and that is because it's a bounce and there's 2 possible roots, then that's the power of 2. We then put y equals at the front, and we're trying to find a polynomial. So you could put a k there if you want, it's up to you. Looking for a polynomial. It is decreasing at the end. It is decreasing at the end, so we know that's going to be a negative. We're not interested in finding the value of k because the question said find a polynomial. So therefore we can choose the value of k just to be equal to 1. So it's minus 1 on x plus 4 on x minus 2 on x minus 5, all to be squared. So and that's the end of that problem. Okay, so what I need you to do now is look at this final example, which is the reverse of what we've just been doing. So this is new. And what we've got to do here is that we've been given the graph, and we're going to use the information from the graph in order to work out how to draw a visual representation of this function. You will never be perfect. It's a sketch, so it's meant to basically just look a bit like it. We'll talk about that in a few moments. So what do we know? Well, we know in order to find out where this graph cuts or touches the x-axis, we put y equal to 0. So we put y equal to 0, and we get this equation becoming this equation. Okay, we've rewritten the equation. What we're going to do now is we're going to put each of these factors equal to 0. So the first factor is x, so we put that equal to 0. The second factor is x plus 3, we put that equal to 0. The third factor is x minus 2, we put that equal to 0. And the final factor is x minus 4, and we also put that equal to 0. What do we know? Well, we know that there's only one of these, because the power is 1, so we know it's a cut. There's only one of these because the power is equal to 1, so we know it's a cut. We know the power is 2. It's an even number of roots, so we know that this x equals 2 is going to create a bounce situation. There's 2 factors, there must be 2 roots, therefore it must be a bounce. There's only one factor for x minus 4, so therefore there's only one root, it must be a cut. So we now write down what the actual roots are. So x is equal to 0, x equals minus 3, x equals 2, and x equals 4. We also know, according to the question, that this is a y equals a plus situation. So we know it's going to be increasing at the end. So we know it's going to, the tail at the end is going to be going upwards. How do we start to draw this? Well, we know that at the end it's going to be coming up to somewhere, maybe where this red dot is. What's it going to do? So it's going to come down to 4. Now, this red dot is a bit misleading. It could be trailing off to the left of it or to the right of it. But what do we know about the 4? We know for the 4, it's going to be cutting. So then it's going to come underneath, and then it's going to turn because it has to come back up to meet the x equals 2. It's cut it at x equals 4. Now it's coming up to x equals 2. Now we know at x equals 2, it's bouncing. So it's going to bounce at x equals 2, so it means it starts to come back down again. But it has to turn in order to go and get to x equals 0. Now at x equals 0, it turns and it starts to go towards x equals 0. And we know it's cutting, which means it will go through. And if it goes through, then it has to turn in order to make its way towards the x equals minus 3. But we know at x equals minus 3 that it's a cut and it will travel through it. Now that is my representation of this graph, and that will be completely and utterly acceptable by the examiners. But let's actually have a look at the actual graph. And as you can see, the actual graph is very different. This bump here is more further to the left and is up the top. This one here is less shallow than the one I've drawn. This one here is about the same height, but I've got it in the wrong place. Here, the line is off to the right of the red dot, not going through it. That was just a guess anyway. You are never going to get it perfect. So that's it. So if the graph roughly looks like it, like the bumps are in the right place, like this is going down at the end, this one's going down at the end, this one's going up at the beginning, this one's going up at the beginning. The bump is below the x-axis between 2 and 4. The bump is below, the bump is above, etc. As long as the bumps are in the right place, it's going through the x-axis in the correct manner, you will get full marks. Now you should notice at the beginning of this presentation there were questions set at the bottom of the first example, and there's also questions set here from the textbook.